Hello, everyone. I'm very happy to be here and present. I work at Spotify on data infrastructure, and I'm Apache Beam committer. Today I'm going to talk about schema-aware PCollections and Beam SQL. My talk will consist of 3 parts. At first, I will introduce coders in Beam, what are coders and how do they work. Then we're going to extend notion of coders to schema-aware coders. We're going to see why do we need schemas and what you can do with PTransforms that have their schema defined. And at last, I'm going to speak about Scio, that is Scala DSL for Apache Beam that we have built at Spotify. And we have built some features that use schemas that are very cool. So let's start. Coders. How many of you have ever written custom coder for Beam? There are a few of you, but if you don't worry. It's essentially a very simple thing. It's a bit oversimplified representation, but essentially a coder and Beam is like interface with 2 methods. One is to take a Java class and make a byte array, and the opposite to take a byte array and deserialize a Java object. Why is it needed? Because Beam is a distributed data processing framework, and you need to be able to serialize Java objects to pass them over the wire to do distributed computation and to run things in parallel on many, many machines. So as a requirement, when you have a Beam graph, each step on this graph should have a coder. Otherwise, Beam would never run your pipeline. It will say that you cannot do this because I need a coder. So from runner perspective, we can guarantee that everything that exists in your pipeline, it's serializable and can be serialized over the wire. Sometimes it doesn't work, and there are different ways to fix it. So for instance, when you have a Java class, and this Java class doesn't implement serializable, you would get a very cryptic error message saying that you need to set coder. So what you can do, you can implement your own coder if you want. It's a Java interface, and you can set it explicitly. But in most of the cases, you don't need to do this. It just works outside of the box. You can also use something called coder registry, where you can register your own implementations of coders. Yeah. But why is it needed? So given that each step of your pipeline has a coder, actually, from Beam perspective, it doesn't really matter what your Java classes are. Because Beam can just work with bytes. It can just pass bytes around the network. It doesn't really need to know that you have the Java class that has a mutable state inside and you modify it. You can just work with bytes. And if you think about portability in Beam, let's say we take a Spark runner and Spark is written in Java, and we take Python SDK for Apache Beam that is a Python. Spark runner doesn't know anything about Python objects. But Python SDK can just provide coders for them and serialize them to bytes. That's how things work. So tomorrow there could be a new runner written in Haskell, and it will still work on Spark. If we would think about it, many of you have data pipelines in production. Typically, what we serialize is some kind of business objects. For instance, we work with transactions if you're like a payment provider, or with music streams if you're a music company. Then one of the ways to do this, if you program Java, a very classic one is to have a Java class with getters and setters. And nowadays, you don't write it by hand, you just use IDE to generate all this boilerplate. And I removed also boilerplate from this slide because it was a lot of. It's like a mutable Java class where you have a private fields and you encapsulate them as a private. And you have public methods to modify and introspect the state. Or nowadays, if you program Java, there is something called annotation processors, where you don't have to write this boilerplate, but you use libraries like AutoValue or Mutable and many others, where you just write abstract class with methods you're interested in, and then things work. Because what happens, Java does code generation for you. Something special about this example is that the class itself is immutable. It becomes more and more popular in Java to write immutable style of data processing, even though Java is not a functional programming language. Some people deny this and just write Java class with fields without any methods or any object-oriented things. Just plain fields. Or we Spotify program Scala. There are many JVM languages. I see that people start to use Apache Beam with Kotlin. That's exciting. Such languages, they have special constructions to define classes. They just have fields and don't have any behavior, any inheritance, nothing. And they're immutable. So in Scala, it's called case classes. And there are many nice language features in Scala that support case classes. You can do, for instance, pattern matching on top of them, or you can copy them. If you do data lakes, you typically have some schema serialization format like Avro, where you have a special schema definition language, and then you generate code to Java, to Python, and so on, or like protobuf. Yeah, so it's like even not a programming language, but still you define schema in it. In all these examples, I just wrote the same thing in 5 different slides, but semantically it was a class with 3 fields of transaction. And there are many nice things for big data nowadays, like, for instance, Spark SQL has data frames that will see it as exactly the same construction for a while. But from Beam perspective, because it uses coders, it's just a sequence of bytes. It wouldn't really even understand that it's the same thing written in 5 different ways, because from Beam perspective, it just doesn't know anything about your code. It can just pass bytes and coders. But actually, we can do better. And the answer for it is schemas. So schemas come to the rescue and save us from all boilerplate and unmanageable pipelines. What are schemas? Schemas, they describe a type as a list of fields. And field has a unique name and has some type. Values of your type become rows that basically are mapping between fields and its values. Everyone used relational databases, so it's exactly the same as in relational databases where you have table, this table has schema, and inside this table you store rows that conform this schema. So our transaction we can represent as a table with 3 fields of bank of type string, transaction ID is a string, and purchase amount is a int 64. And databases typically have some kind of type system. So Beam implements schemas and it has own. It has a set of primitive types, bytes, short, long, and different sizes of integers, decimal, booleans, strings, etc. As well, it allows you to do composition. For instance, you can have an array of integers, or you can have an array of strings, as well as you can have array of arrays of strings, etc. There are also maps where you can choose a type of key on a value. You can have, for instance, map from string to int, or from int to array of strings. As well, you can do nested rows when you have a row nested inside the other row. Nullable fields are supported, so you can have null value for any of that, but you have to explicitly tell schema that this field is nullable. It works in a very similar way as it works in Java, as optional works in Java. Let's go back for a second. You remember we had this coder interface that was essentially, it used byte array as a universal representation for any type in Beam, and it had function to transform from Java objects to bytes and get back Java object from byte string. Now we can have an extension called schema coder that is basically implementation of coder, but instead of using a byte array as a representation, we can use a row as something better. Given that, Beam will actually know that it's not a byte array anymore. It's something that has structure, it has schema, and it can reason about it. And we don't need to write this binary serialization code anymore because you get it for free from Beam, because Beam knows how to serialize any kind of row for you. And you actually don't even need to implement this interface yourself, because out of the box, Beam has very efficient implementation of automatic creation of these coders. If you use auto value, or if you use Java POJOs or Java objects with fields, you get it for free. You just need to add annotation called default schema to your Java class, and it would work. as well as many sources and sinks in Beam. They support it. For instance, if you use Avro objects, you would actually get a PCollection that has schema. You can call PCollection.getSchema, and it will return you a structure of it. There are others, for instance, BigQuery and PubSub, that support it as well. Tomorrow there is a talk about protobuf support for schemas, so if you want to learn more. But essentially, now our runner become much more aware of what's inside of your pipeline. It has ways to know that some of your PCollections have schema and has functions to transform SDK values to rows and back. What it means when we have a PCollection of transactions, it's not just a PCollection with bytes anymore. It has a schema, and it can transform values to rows. Now, a very similar example to what we had on the keynote today. We can actually take transactions, and we can apply certain PTransforms. Out of the box, there are many of them in Beam. For instance, we can do filter. And in a filter, we pass a field name as a string. We don't write Java lambdas in this case. And we can pass an expression to use for filtering. As a result, you'll get, again, PCollection of transaction, and this PCollection will keep the schema as your input, because it will just perform filtering. In this case, we are going to filter transactions coming from particular bank. So the bank field itself is not interesting anymore. And what we can do, we can just select 2 remaining fields. What will happen, you'll get a PCollection of rows, because we cannot represent it as a Java type anymore. But many people like Java types. Don't worry, we can actually get Java type back. If you have a Java class that has exactly 2 fields, we can actually convert it back. And it's safe. It will be checked at pipeline construction step that schemas match, and if something is wrong, you will get an error. It works in streaming as well, and both in batch and streaming. So it looks very nice and concise, and it's like super readable. But if you are not yet convinced that it's a good API, let's do a join. You saw today that joins in Beam are very complicated. It requires you to do lots of boilerplate. But with schemas, it's easy. It's just line of code. You can join one PCollection with another one. And to do this, you just need to specify field name of a key you want to use. And as a result, you would get structure with left-hand side and right-hand side as a nested rows. To work with that, we can use select again. So let's say we are interested in user ID from purchases and amount from transaction. As you see, select is actually very nice because it allows us to select nested fields as well. And then we can do group by. So for group by, we can have multiple aggregates as much as we want, and we specify a list of fields as just strings. Specifying things as strings, many people would not like it, but in some way it's nice because it's safe in a sense. There is pipeline construction step where schemas are validated. It's nice because now you can actually write pipelines that are configurable by users. So you can have a config file that you would create pipelines from. We do it a lot at Spotify to enable users to configure their ETL steps without writing any code at all. There are more transforms. One is called unnest. I really like it. There are many data sources. One of them is a BigQuery that support nested rows. So you can have a row that will, let's say, user, and it has a nested structure in it. But many other data sources don't support it. For instance, MySQL. As I know, it doesn't support it. So there is something called a nest that basically allows you to have a fat structure. So the schema with only primitive types as an output. What it would do, it would put delimiter between elements in the path. So user and nested field ID will become user underscore ID. And you can choose which delimiter you want to use. As well as it's not magical. If you want something a little different, you can actually implement your own PTransform if you want. Something we contributed from Spotify is called cast. It allows you to cast between different types of schemas. There are many cases when you want to have a little change to your schema. Let's say you have an amount as int32, but you want int64 because it's what you store in database. You can perform such cast. Or as if some field was non-nullable, but in your database it's nullable. So you can cast one schema into another. It can also drop fields for you. So let's say you got not 2 fields as an input, but 3 or 4 or 10. You can cast to the subset of fields as well. Out of the box, it does only safe casts. So if you try to cast strings to integers, it would complain at pipeline construction step. But you can also disable this if you feel lucky. There are things and sources that support schemas as well. Doing such simple operation as reading from PubSub and writing to BigQuery is simple. For this, you just need to connect PubSub to BigQuery. And because both of these PTransforms, they know about schemas, you don't need to write any extra code. Before that, you would have to actually write a function that would format Avro objects into types that BigQuery can understand. That's a lot of boilerplate that is very easy to make mistake and very hard to maintain. Beam SQL is probably one of the best things you can get from schemas. Given that many of your PCollections have schema right now, you can see them just as a tables and database. So what Beam SQL allows us to do is to write SQL to transform our PCollections and get another PCollection. And you can mix this in your pipeline. So you can write Java code, then you can do SQL, and then you can write more Java code. The way SQL does, it's basically a DSL that has own compiler and optimizer. So you write these SQL statements, it would compile it, and it would basically translate it to the set of PTransforms that we have seen in the previous slides. So there is nothing special about it. It uses calcite for doing query optimizations, and it also works with streaming, and as you have just seen, there is generalization of different generalizations of semantics for different kinds of windows, even in a streaming way. We use it at Spotify for our experimentation system to basically abstract it over all Java code, and we just showed them SQL. And that's how non-technical users who are domain experts can actually express what they want without writing any Java code. It's super powerful and easy for us as an infrastructure team to maintain. There is going to be talk about Beam SQL. Tomorrow there's going to be more of a deep dive if you're interested in. Parallel do functions also support schemas because schemas are part of the Beam. Without schemas being part of the Beam, it wouldn't be possible. But what you can do, you can write a do function that will take a particular field as an argument. You just need to add Java annotation for it. It would also do type check for you at pipeline construction step. So if you mistype something or types don't match, you'll get an error. This way you can reduce the amount of boilerplate, or you can work with data that has structures that you're not super certain about. Now I'm going to talk about Scio. Again, Scio is a Scala DSL we built at Spotify. It's a small, or not really small, layer on top of Java SDK, and it uses Scala as a language. At Spotify, we like Scala because it allows us to write very small and concise code, and it's a very expressive language. What we do in Scio is very similar thing to Spark. If you use Spark, it looks super similar, or if you use Scaldin, the same. It's very little code to write, and it's super expressive. It has a great, Scala as a language has a great type inference, so you don't have to specify types. As well, it has a nice support for things like macro or a generic derivation that we use. As an example, what we did in the earlier versions of Scio, when we started to use Dataflow, we used BigQuery as a part of our ETL steps. So we do a very heavy BigQuery query, and then as a part of your data pipeline, you read output. What we did, there is like a very common operation where you take output of a BigQuery and you map it to some case classes in Scala. It's again boilerplate to write. So what we did, we wrote a macro that did it, as well as it does dry run of your Dataflow jobs, and it checks the schemas are fine. We did this macro, and it was very successful within Spotify because it made our engineers very productive. And then people asked for the same for Avro. So we did one more macro that will support Avro. And now there is something called TensorFlow examples. It is a format for machine learning. We did one more macro for TensorFlow examples that integrates it with case classes. As you can see, it's a lot of macros. But we did one more macro in 0.7. We did it to optimize coders in Beam. So 0.7 was something we released like half a year ago. What we did, before we used Cryo, and Cryo is a Java library for serialization of Java objects. You can serialize most of Java objects, and it uses some runtime type information to generate bytecode. In our case, what we need to serialize is Scala case classes that have much more guarantees and much more simple than generic Java class. So we don't really need the whole power of Cryo. So what we did, we wrote macro that works at compile time. And this macro works 25% faster. By 25%, I mean our pipelines are 25% less expensive right now. So why it's 25% less expensive? There are two reasons. The first reason that it's very specific. So it supports much more narrow case. That's why we were able to provide much more efficient implementation. And the second one, that Scala gives us more type information at compile time that you can get through reflection in Java because of type erasure. If you want to learn more, check out this blog post. By the way, if you use schema coders, and if you would switch from Java serialization to schema coders, you would see a very similar performance boost. Because schema coders in Beam, for instance, in case of auto value, it would do bytecode generation as well. So if you want to save some processing time, please switch to schema coders. They're great. What we did in 0.8, we extended this macro to support schema coders. So now it's not only that we are going to produce generic binary coders, but our PCollections will have schema. You just need to write a case class and you would get it at compile time. Basically, if you would remember, we maintained this macro that did mapping between BigQuery and case classes, and one more for TensorFlow examples. Now we don't need to do this anymore because we just have a macro from case classes to rows. And from rows, we can convert to many different formats. For instance, we can convert to BigQuery format called table rows, or to generic records for Avro. And actually, from maintenance perspective, maintaining a macro is very hard because it uses very internal to Scala APIs that are changed in each Scala version. Writing code that works with rows and with Beam schemas is very simple. So now, if you want to add a new format, like a mapping between case classes and CSV files, let's say, it's very simple because you can do it with schemas. And out of the box, Beam supports many of this. For instance, now what we can do, we can take Java object and convert it to case class and back. So that's what we do. In Scio 0.7, we allow you to do automatic type conversion. So you can have a collection of type A, and you can have collection of type B. And then we can convert from one to another just by choosing the type that we want to convert to. The way it works, it's going to be a compile time check. How is it possible that it's compile time? It's very actually easy because at compile time, Scala will tell us that there is type A and there is type B, and we're going to use some mechanics to get schema of type A and type B. A type A can be a Java class, and type B can be a Scala case class. So if types don't exactly match, you'd get compile time error saying, printing you a very nice ASCII table and saying that types don't match, please fix it. In this case, names didn't match. As well, we do the same for Avro records. So if you used Avro in Spark or if you used Avro in Beam, there is like this step where you take schema and you do code generation. And the code is in Java. And we did it so what we did at Spotify, we generated Java code and then we did mapping from Java code to Scala case class, or like semi-automatic mapping. And still we kind of generated Java code. Now we don't need this to do anymore. We just give a schema string to Avro IO, and we can convert it to case classes. And it's going to be also safe at compile time in most of the cases if you can know the schema. We also did support for Beam SQL. So if Beam SQL is a DSL for SQL to use Java SDK, and Scio is a DSL for Java SDK in Scala, we put one DSL into another DSL. The way it works, in Scala, there is language feature called string interpolators. That basically it allows you to embed DSLs inside Scala. So it allows you to do your own parsing and transformation and compile time of things. So basically, it's a macro inside the macro. What it allows you to do, it allows you to do this $ references of PCollections from SQL strings. So you can actually do a join or much more complicated examples in this syntax. And it would actually do type checks, because there are many things that can go wrong. For instance, the queries that we write can be not a valid SQL query, or we don't actually know that our user collection has username and email fields, or even if they exist, the types can be different. But as you can see on these slides, all types are annotated, and the string is constant. So we don't get it from any service. We know the compile time. It means that we can actually do compile time checks for this. And that's what we do. So if you would mistype SQL string, you would get a compile time error message saying that parsing failed, please fix your code. So in this case, we mistyped instead of from, we typed from. And it's nice to get such errors at compile time because it significantly increases speed of iteration, because it's much faster feedback from compilers than from running your pipeline. As well as in general, there are more guarantees because it checks, type systems check more, they give you static guarantee that doesn't have any problem with exponential number of combinations that you can have in your pipeline if you have some options. If you would use some columns that doesn't exist, you would get a different error message that will say basically, this column doesn't exist in this ASCII table, please fix it. Or if you would use, let's say, username that is a string, and instead you would specify as a return type that you expect integers, it would also give you that, I cannot cast it, it's not compatible, and you can fix it. This is very powerful because it allows data engineers to spend less time, and also some things are nice in SQL, the things that are not nice we would write in Scala. As a conclusion, Beam schemas, they extend Beam with the knowledge of structure of your data. It's not just a byte sequence anymore. Beam will really understand the structure of the data, if there are fields, and what are the types of these fields. There are many built-in transforms that simplify and reduce the amount of code that you have to write. As well as you can add your own transforms. So if you build like data warehouse where you have thousands of pipelines, you can make most of them just generic pipelines that will be parameterized by some configuration file or will work on arbitrary schema. It's very powerful. We do it at Spotify a lot for our experimentation system. In the future, you can see there will be integration of schemas with portability and support in other SDKs. What that means, you would be able, for instance, to pass Python objects and run SQL on top of them, or Go objects. As well as, if you think about it, now our pipeline graph will have much more information, and there are certain optimizations that are possible. For instance, you can understand that certain field was never used in your pipeline. You can just remove it and not even read it. It's not a proper SQL optimization, but still it enables some of such optimizations that will reduce processing time. That's it. Thank you for your time.
Thank you so much for your presentation. We are going to open the floor for questions now, so please raise your hand if you'd like to ask anything. All right, there we go.
Have you had any issues with the schema mutation, and how Or have you solved that? If you have, for example, if you change your schema.
At Spotify, most of schemas we have, they keep backwards compatibility, meaning that you can only promote fields to, let's say, from int 32 to long, or can add fields that have default values, basically, that are nullable fields. So what we use right now, it basically has all schemas that are part of our code base. It means that we can check them in our CI/CD process before deploying pipeline. And because even though if underlying data source that we use, it will change schema, it would be backwards compatible, meaning that we can always cast it to the previous version. In this sense, we don't have it as a problem.
Thank you. Next question over here.
Hi. When usually we use auto-detect for various schemas in various systems, the program actually goes through the data for 1,000, 10,000, 1 million rows, tries to identify the data type, and then gives up after it has a certainty. How does that go? Do you do a full class scan, full object scan, or you go only for a particular number of rows for the auto-detect schema in Beam?
I will repeat the question to make sure I got it, because I don't have this voice coming to my side. I don't really hear the question. But the question was, let's say you do streaming pipeline and you change your SQL statement. It means that you have to reprocess all the data from the beginning of time, almost. Did I get it right?
Let me give you an example. You have a class that has like various ABC values. And after the 1 millionth row, you also have some integers. And usually, many systems would see ABC, give up after like 10,000, 1,000 rows, 1,000 entries, and would auto-detect it as a string.
Oh, so I mean, does it support profiling of data to derive schema? I'm afraid it doesn't support such things. But there are different projects in Beam ecosystems that do this. I think there is something in machine learning world, I'm not entirely sure. But out of the box, you have to know schema at pipeline construction step. So the best thing you can do, for instance, when you construct your pipeline, you can go to your data source and try to inspect it. If the data source has schema, let's say it's an Avro object, you can get the schema from GCS and just get the first one from the first file. It often works well. Or if you use BigQuery, you can dry run your query and you can get it as well. But if you have unstructured data like JSON that doesn't give you any guarantees, you can probably try to predict your schema and try to kind of run pipeline like that. But you can break any time, right?
Okay, so there's still need to like take a look over the data and see if everything goes well.
Yes. So the limitation of this approach is that it requires you to know schema when you build a pipeline. So there is no way how this can, at least if you use this mechanics with schema coders, there is no way how the schema can be dynamic, because you have to set schema and then you can only run pipeline.
Okay, thanks.
All right, thank you. Next question.
Hello. I was wondering, how do you support hierarchical data? For example, on the join, you request data with...
Can you speak closer?
Closer. Okay. On the join, I saw you request hierarchical data to say, for example, I want the left data ID. How well do you support this kind of feature? Like...
Sorry, I didn't hear the question. It doesn't come to my side. If you can speak louder.
Yeah. Do you support hierarchical data on the key to request the data? Do you support hierarchical data, or do you just request data that are flat? Yeah, just if
I think we can. I'm not sure completely I got your question, but we can talk afterwards.
So do we need any schema registries to register here? Do we need to register the schemas in some kind of a registry, schema registry? So if in case I'm transferring, I have my data in a schema, and if I'm transferring data from a Kafka pipeline to Beam and and encode this data on the Kafka side, how would Beam be able to decode it? Do you have some kind of a central repository of schemas?
Yeah. So Beam core itself, it doesn't have support for schema registries, but if you would use
Confluent registry or Hortonberg's registry or something?
in Beam SQL, there is support for schema registries. You can use systems like Data Catalog or others like Hive Metastore. But in a Beam core, there is no such thing. So you have to do integration yourself.
All right. Do we have any more? We do. Okay. Over there.
You mentioned you let users create pipelines through config files. Can you develop a bit on that? And do you let them choose filtering and aggregation, or is it only for very simple pipelines?
So you can do two things. You can either programmatically build PTransforms, and then you can use strings as dynamically, because they don't require you, in most of the cases, don't require you to do any Java code. And what we also did at Spotify, before these PTransforms were as stable as they are today, we just did generation of SQL code. And you can use many Java libraries to do it. It's actually easier to do generation of SQL.
Okay, thanks.
All right. We have time for one last question, and then we'll go for a short break. Anyone? Last opportunity. Okay. Thank you so much for your presentation and for answering these questions.
Thank you.